people take disease as a matter of fact. Oh, people die. But why? Why do people have to die?
There's a bunch of things out there, how people can look at their DNA.
So genetics is not a silver bullet, but it has very clear medical actionability steps that anyone and everyone who's interested in longevity should take and incorporate into all their protocols.
You mentioned doubling the lifespan expectancy in the next, I think you mentioned 150 years or something like that.
I could also see a future where AI basically combines with genetics, and we have such a deep understanding of the human genome that we could literally optimize every single letter to basically increase our longevity, and that would just be almost like a pill, a longevity pill, right? You just take I want to live another 10 years, pop.
Kian, thank you so much for joining me on the show. So happy to dive into the discussion together and learn more about your journey, how you started Nucleus and how you are making big waves when it comes to genomics and longevity.
Yeah, I mean, absolutely. So happy to be here. We just had a big product announcement, so the entire office is kind of euphoric. I'm so excited. The energy right now at Nucleus is just amazing.
It's amazing, and I'm so happy that we have scheduled it that way. So yeah. I can definitely feel the energy. Just when you joined, it was clear that there is something big going on, and we'll definitely cover it during the chat. But before we get to it, I would love to understand how you basically took things off the ground. What were the initial moments where you realized, okay, this is something that I would really like to be doing? Because you made that decision extremely early on, and a lot of people struggle with finding what is the goal, what they would like to go after. And I find it remarkable that you were able to pull it off so early. And I think that there is something to learn from. So I'd love to hear from you. What was the thought process behind it?
Well, first off, thank you for the kind words. I think, Nucleus at this point I've been working on for 5 years, but I like to say that, in my small lifetime, I'm only 25 years old. It's in a way, it's kind of 20 years in the making in a way. And that's because, just to understand a little more about me, I'm a first generation American. Both my parents are actually Persian. So they escaped Iran during the revolution. The government of Iran actually tried to murder my dad, literally. So he had to escape. He eventually ended up in Canada, then America, and he sort of has the classic immigrant story where he's flipping hamburgers at McDonald's, eventually becomes an ophthalmologist or eye doctor, right? So I'm kind of my mom as well is an extremely smart, talented woman, also a Persian, meets my dad. They moved to Brooklyn where I was raised, and so the backdrop of my life is sort of the determination of immigrants with the opportunity of America. And I think unfortunately the story of Nucleus begins with a personal tragedy. My cousin actually. She went to sleep one day and she didn't wake up the next day. She died in her sleep. She had yeah, thank you. She had a condition that can cause a heartbeat, sudden death, and so she passed away. And we actually didn't know she had this. I mean, it was a complete sudden death, and doctors attributed it to a condition actually called long QT. And long QT is interesting because it's a condition that if you know you have the genetic marker, you can actually take something called a beta blocker, which is a drug that reduces your risk 10x of dying, right? That's kind of the power, a great example of some of the power of a genetic test. But if you don't know, obviously, then you can't prevent the condition. There's no other phenotypic signal that would make you know. And so I asked my parents at the time, I was very young, I said, how does this happen? How does this happen? They said, oh, bad genetics, bad genetics. That was the extent that I understood the problem. Eventually, though, I started studying genetics, and what I realized is that disease isn't really like an inherent property of human beings. And I think, another way of saying this today is kind of in the longevity movement context. Like people take disease as a matter of fact. Oh, people die. But why? Why do people have to die? It just never kind of intuitively made sense to me. And so with that, I began my quote unquote career in genetics, genetically engineering organisms. I actually joined one of the first do-it-yourself gene editing laboratories in high school where we engineered yeast to make them eliminate. We added bacteria to make them resistant to antibiotics. And I kind of love this beauty and depth of biology. And one thing I didn't like is that working in a wet laboratory where there's so many pipettes, there's so many reagents, et cetera, you can make mistakes and then you have to redo the entire experiment. It takes so long. I wanted something a little bit more iterable, right? I liked the computer because it was kind of a conduit to my mind. I could just, think of things and then program it and it would just basically appear and I could click the delete button and that would be that. I wouldn't have to kind of restart an entire experiment. So I want to, in other words, combine this kind of beauty and depth of biology with this sort of iterability of programming. And so I went to Penn and I studied computational biology there. And I was only at Penn for around a year and a half until I'm sitting in biology class one day. Okay, you can imagine a large, auditorium. There's many kids sitting there, and the chairman of the biology department is giving a presentation. Okay, and he puts up a slide, and the slide basically shows the decrease in cost of reading an entire human genome. So you can think of your DNA as like 1,000-page book. It used to be $10 million, literally $10 million to read all 1,000 pages. But then in 2020, when I started Nucleus, it was around, $1,000. So 10 million to $1,000 in about, 20 years or so. And I thought, that's, obviously this price is going to converge nothing. We're going to be able to read the entirety of someone's DNA. And in reading the entirety of someone's DNA, we can give basically the most accurate assessment of someone's genetic risk for disease, family planning, what drugs they should take, etc. And with that idea in mind, I said, okay, you know what? I have to build this kind of application layer for DNA. And so I actually left school. But let me tell you, immigrant parents, you do not mess with them. Okay. So I did not tell them that I was leaving school. Actually, I did not. I told them that I was actually working as a professor at Penn. I said, okay, I'm going to take I'm going to go for a year, but also it was COVID too. So it was kind of weird. So I'm going to take this year. I'm going to work with this professor at Penn. So I actually programmed a fake email from a professor at Penn. Sorry, mom and dad, showed it to them. And then the entire year, I just worked on Nucleus. Literally, I filled in 18 subject notebooks on computational genomics. And I realized, wait a second, I kind of identified that you can basically provide this you can combine over 70,000 genetic tests into one swab, one test over 1,000 different conditions. You can provide the most comprehensive assessment of someone's genetic risk for disease that's ever been available. And I remember I went to my parents, I said, Mom, Dad, I have this great idea. And they said, okay, we're kicking out of the home. I said, kicking out of the home? Come on. And then I said, okay, well, I got to figure out how to raise money because, I'm not going to have a freaking home. I have to support myself. And so then I cold texted an angel investor. This is all true, by the way, which is crazy. Just looking back, especially now with this launch today, so I always, when we do launches, I look back, I'm like, this is crazy. I cold text an angel investor, get on the phone 2 weeks later. I gave him the worst pitch ever. I'm go, Nucleus is, there's no idea. 45 minutes pass.
And if I don't get money, they will kick me out of home, right?
Exactly. Please. So I'm going, Nucleus is, I give him the worst pitch ever. And then he says to me, I remember 45 minutes, literally 45 minutes straight. He doesn't say one word. I just, I'm blah, 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 blah. He goes, so it's a better 23andMe? I'm like, exactly. And I was like, maybe I should pitch it like that. That's a better way to play it. But he ended up investing $100,000. So that's how Nucleus got started. So now I'm, one person in my bedroom with $100,000. But, the most important things I actually had already, which was an imagination and determination. If you have those things, everything else falls into place.
It's a great start, and I think it's an extremely strong story. And I'm sad that their journey had to start the way it started for you with experiencing a loss in the family. Unfortunately, I feel like these strong moments in our lives are the moments that actually help us to open up, be mindful, see new opportunities that we would not see otherwise. And I hear those stories very often. So as much as I understand that it is not pleasant at all, it opens up new opportunities and new horizons, and it certainly did for you.
Absolutely. I think, whenever we are tested most in life, in a way, it's that when the true growth happens, right? I think God tests each of us and we have to rise to the occasion. If you do it, you keep kind of moving up in life. That's kind of how the way I see it.
So it seems like, in 5 years, and I think like when it comes to building companies and especially building companies in biotech, 5 years is nothing, right?
Yeah, in a way, yes, in a way, no. If you go to Silicon Valley, 5 years is very long. If you go to classical biotech, it's like 5 years. It's like, my God. So we're kind of a mix between the two,
Yeah, you barely do a trial or something when you want to test things out. But from my perspective, you have gone through a lot, and it seems like very nice success story. But I assume that before we get to something that sparked a lot of joy and happiness earlier today, what would you say were some of the toughest times in terms of navigating that journey from getting the first check for 100K all the way to today? Where did you feel like, it's really, really tough?
Well, definitely being in my bedroom was extremely psychologically difficult. being by yourself working on a project every day for a year where there's no mentors, there's no friends, there's no support, emotional support, there's no school. The entire infrastructure of your life basically collapses because you're out of school. um, no one knows what you're doing. You don't even know necessarily what you're doing. The level of conviction and level of in some sense maybe delusion, and the level of psychological persistence that one has to have in face of extraordinary odds. I mean, it is literally like, trying to push a mountain and believe that you can do it. It is almost a fool man's errand. Um, that was extremely difficult. I mean, there was a very intense, long days, and there was a lot of kind of self consoling to try to make it through. And then the first big break was the first check, the $100,000 check. And because at that point it starts becoming okay, maybe there's some sort of external validation, right? At some point, you can only sustain yourself so much on internal, just purely internal, kind of but one thing people don't understand often is when you go deep enough into the intellectual frontier, you start kind of seeing things, right? You kind of like, the reality starts almost like kind of falling around you. Like true obsession requires such a degree of intensity that you're very close to losing your mind. And I'm not saying that I wasn't saying, I don't think I was a month away from losing my mind, but toward the end of that time period, it became very, like, again, it's like a psychological thriller. It's almost like when you see these movies where someone's in a living room, but then they're seeing something inside of them that's like some sort of, maybe they're hypnotized or something, that they're seeing like a whole other world, right? It's sort of like that. It's like, at first glance, if you look at me, you just see me in my bedroom, kind of seems fine. I have food in my tummy. I'm in a safe environment, right? There's nothing physically wrong. But then the emotional commitment and dedication was so extraordinary that, even to this day, I still think I'm kind of recovering from that level of kind of pulling the Thoreau, pulling the Walden, right? And I think also to some extent it's a good lesson in the fact that if you go sufficiently intense enough on your craft, if you really shut out society for a year, you can become undoubtedly one of the best in the world at what you do. And I'm still benefiting, and Nucleus is still benefiting from that level of extremity of focus because we simply have an intellectual foundation. We have an understanding of the field that no one else has. We see the matrix. And that is a far greater alpha, that is a far greater moat than capital, or even arguably like kind of technological moat, than one could ever ask for or have.
And like when you go, when you think about like when you mention going into the very details and understand all the intricacies of everything, like was it just the thought that you had, okay, like I have to go very, very deep to become an expert in this particular thing? Or like was it natural or was it something that you picked up on the way?
Good question. I think you know, I I at the time, so I actually say this sometimes to young founders. I say capital corrupts you. The reason why capital corrupts you is because, well, for a lot of reasons, but one of the reasons, especially when it comes to creation, is that um, capitalism and raising capital is really about scaling up some fundamental, ideally technological insight, right? Ideally, right? That's really what capitalism is about. And the thing is, the second someone gives you money, it starts this process where you need to scale something up. In other words, it short circuits the part before you're supposed to have capital, which is the creation part. When you're supposed to make the discovery, when you're supposed to identify the technology, when you're supposed to understand the world really deeply. I always like to tell new founders, you cannot create unless you understand. The first step is to understand the thing very deeply, and then you can productize it, and then you can create it. And so at the time, I was actually blessed with no capital, no resources. Because when you have no capital, no resources, you're trying to circumvent the process. In other words, you do only what you can possibly do. Like I never even imagined in my bedroom that I could hire someone. That never even went through my thought. I thought if this is going to get built, I have to get it done. If I'm going to get it done, I have to understand everything, right? It's like almost a survival thing, right? It's like, oh, it's like, you have to, I don't know, go and lift, 100 pounds of groceries every day. You have no help. You're going to get you're going to get pretty, strong, right? It's like the same thing. And so that's the kind of the way that I think about it. So it was in a way out of necessity, but it was also out of curiosity. I loved the material. I am insatiable in that way in trying to understand how it works. I loved genomic prediction. I thought it was absolutely fascinating. So it's both out of survival and curiosity, but those kind of two things of kind of fear and love, it's a great combination because, it's kind of like push and pull that then motivates you and
Yeah.
pushes you forward.
But I think it's such a great insight that you mentioned with the level of investment that basically it kills the creativity of it, because if you land a big investment, your responsibility should be scaling it up, and if
Yeah.
you don't have it figured out, right, you might be investing into wrong places.
And it happens a
So
lot, actually. It happens a lot in Silicon Valley. People
it
don't
does happen
appreciate
a
it
lot, yeah.
because people actually, when they look at a company that raised money, they make the fallacious induction that, oh, they must have their shit figured out. But most actually they don't. That's why most companies fail, because most companies are like, little toys or something, little passion projects. Not that toys or passion projects aren't important; they can be productized and scaled up. My point is that someone actually hasn't done the work, and I'm a big believer in building companies where you do the work. Right, it's like a professional athlete, right? You can't expect to go, play in the NBA finals if you never picked up a basketball before, right? Obviously, there's always to start when you're playing in your local playground first, right? Before you actually make it to the biggest stage in the world.
And like you mentioned that your biggest probably trigger to move that direction was seeing how the cost of basically DNA sequencing and everything drops down significantly, right? How you basically can do the research with a fraction of a cost.
Exactly.
How do you see that evolving into the future?
Well, so today the price of sequence, you can do Nucleus today for $400, which is amazing. It used to be 10 million. So, that's amazing. I actually think I said this earlier in the Technology Brothers podcast. I think, within 5 years, you can see a genome for a couple dollars. I know it sounds outrageous and crazy, but I really actually believe that. The reason why I believe that is because if you look at the trends, that's exactly what all the trends converge on, which is there's this massive commoditization of the infrastructure layer, right? Which is basically the layer that produces your raw DNA file. So the way this works, everyone understands, is, you get a DNA kit that looks like this. You open up this DNA kit. Inside, there's a swab. You take this swab, you go like this, you stick it in a tube. Once you stick it in the tube, it goes to our lab. Our lab then processes the DNA and basically produces a raw whole genome file or a raw large DNA file, which then we run through all our informatics and all our analysis pipelines. So we kind of, control this entire stack from the distribution all the way to actually an analysis of the DNA file. And what's so interesting is that like as a customer, you're thinking to yourself, okay, like one swab, you would think like maybe this is like you have to take multiple tests. Maybe it looks at one gene or two genes, because most genetic tests look at one gene, two genes, right? But actually looks at the entirety of your genome. So old tests like 23andMe or Myriad, et cetera, they looked at one gene, or they looked at a small fraction of your DNA. But we look at all 20,000 genes and all non-genic regions too. And that's what I'm saying to you, is that this chart of the decrease in sequencing, it tells a story. And that's also another good lesson for founders, which is anytime you see a massive decrease in cost, know that real time in the capitalist marketplace, the consequences of that cost reduction is playing out real time. And you can almost always assume that the incumbent is relying on old models of technology, old models of how the world works. And with that, that's where startups really crop up and can really scale quickly.
And so I assume that as the price further drops down, and with like the rate how AI is evolving, etc., the insights will only be getting better and better,
Yeah,
and
I
the
think
cost of
so.
it will be
Costs are
very
going to go
insignificant.
down. The predictions going to become better and better. The predictions today are very good across different common diseases, but it's only going to get better. I mean, that's indubitably true. Yes.
And could we tap into basically the competition and how you stand out? You mentioned 23andMe already, but there's a bunch of things out there how people can look at their DNA. But it seems like you are basically not leaving anything on the table, because you are looking at the whole thing.
Exactly.
And that's kind of the narrative of what you go after.
Exactly. So we don't only, there's many things that we do differently, but let's first start at the testing layer. So you can think of genetic test, right? There's the testing layer where you get the some read of someone's DNA. Then there's the analysis layer where you analyze that read of someone's DNA, right? So, we use 23andMe. Let's use 23andMe as an example. If you take like 23andMe, if your DNA is 1,000-page book, they look at one page. Okay. Nucleus looks at 1,000 pages. So it's dramatically more reading of your DNA. And that enables us to then analyze a lot more. So what does that look like practically? Take a condition like breast cancer. 23andMe for a while looked at three what's called BRCA variants, or genetic markers that dramatically increase your breast cancer, right? Three of them. We look at 2000. And then we also look at all the other known associated genes with breast cancer. So we look at basically orders of magnitude more genetic markers that most dramatically shape someone's risk. And then we employ new kinds of models where if you don't have one of those kind of really bad genetic markers, we can actually further stratify your genetic risk by combining up to 1 million markers in your DNA, where each has really small effect into scores. And so, in other words, what I'm trying to say is that not only has the actual testing become dramatically innovated, because you can actually read now all 1,000 pages of your genome book, but also you can actually analyze all 1,000 pages. So these two things converge on the Nucleus platform. We can get insight into a huge number of common and rare diseases, traits, family planning. I can keep going into what those actually mean, but that's kind of the beauty of what we do and how we're really unique, honestly, because very few, if any, companies have ever really brought this together and productized it at such a price point and done it in a very scalable fashion.
The quantity is definitely one thing to look at it, right? If you say that 10,000 page book is compared to 1 page book, then of course, like it's a lot more data, but also like for a human brain to be able to absorb, and for us as people to be able to take actions. What I experience a lot of times that you do all of these tests, you get a lot of results, you get a lot of reports, and it's tens or hundreds of pages of material that you do not understand.
Sounds like a bad report.
So I would love to hear from you. How do you make this actionable? How do you actually help users to comprehend that huge amount of data that they have suddenly received, right? And
Absolutely.
Because in the end, it might be changing one little thing in their habits that will make a huge impact.
Yeah,
versus being lost in, okay, these are the numbers, these are the metrics, this is the factors, this is what I
well, first off,
have a predisposition for, etc.
Have you done our test?
I have not yet.
Okay,
I have done a lot of other tests.
You haven't seen the good reports then yet, because what you describe it is the exact problem. Where what happens is you do genetic tests, they give you a 50-page report. I can tell you, I'm the founder of Nucleus. I've done every genetic test known to man. I've seen every single one of them. Literally, the vast majority are complete garbage. Okay,
I mean,
because they don't know. They just don't know how to do real genetic analysis. Like, it's actually scary, because what happens is they give you these 100,000 markers or something, and then they try to associate each one with some trait. But the reality is that each of those variants, each of those genetic markers, have extremely, extremely small effect. So it's kind of like you're punching at the air almost. What we do is very different. What we do is, first things first, is everything that we do is packaged up by a per disease basis. So when you actually log into Nucleus, we take great pride in our UI UX. We really think genetics, genetic science, and genetic results should have an interface very similar to kind of the best consumer software businesses. So all our reports are organized by disease. And what we do an innovation is that instead of looking at, if you take a disease like, say, heart disease, for example, right? It turns out, actually, if you look at a condition like heart disease, someone might want to analyze one genetic marker. They find one genetic marker. They say, hey, I'm going to look at this one genetic marker. Oh, this one genetic marker means that you have increased risk for heart disease. Let me tell you the problem with that. The problem with that is it turns out that one genetic marker has extremely, extremely small effect on your heart disease risk. So what do you have to do? What you actually have to do is you have to take that genetic marker and combine it with up to 1 million other associated markers, and then consider the combined effect of them, and then put someone in a distribution. Right? This is called polygenic scores. And this is something that gets fundamentally missed because it actually requires a lot more statistical and algorithmic sophistication. Right? It requires, they say, a lot more technology, right? Which is something that Nucleus has actually pioneered, especially by our chief scientist. And so one of the first things that we do is we organize it by disease, so it's very clear what you get analysis on. And if you click on the report, we actually first look for really bad stuff in your DNA, and then we actually run these polygenic models. And so we really lead with risk, because when people do genetics, they don't necessarily care, do I have this genetic marker, do I have that genetic marker? They want to know, what can I do with it? That's what they want to know. People use genetics like a blood test, right, as a tool to try to understand what different preventative measures should I take. And I want to talk about this because it's really important. If you take a step back and look at the longevity chart, okay, that we've had over the last, 150 years or so, in 1870, it was around, around 40 years or so in the United States was how long we expected to live to. In 2024, it was around 80 years. Effectively, there was a doubling of life expectancy in the last 150 years. One of the things I always like to say at Nucleus is our mission as a company is to once again ensure that at the base case, worst case, we double life expectancy again in the next 150 years, because that's what happened. What happened is we doubled life expectancy in the last 150 years, so we should double it again in the next 150 years. If we ask ourselves what drove that increase in life expectancy, it was a huge plethora of technology. It was antibiotics. It was pasteurization. It was, sanitation. In other words, it was a range of different technologies that came together that enabled the increase in life expectancy. I see the same thing happening today, and I see genomics being one of the most foundational pillars of that. The reason is because if you look at what's actually killing us today, if you go back to 1850, well, the number one thing that was killing us was bacterial infection, right? That was the number one thing that was killing us. It was killing everyone. What happened? Well, antibiotics happened, and it saved millions and millions and millions of people's lives. Today, what's the number one cause of death? By far, it's chronic conditions. What's interesting is antibiotics was responsible for more than 50% of all deaths in 1850. Today, more than 50% of the deaths in the United States is because of common diseases, cancers, heart disease, Alzheimer's, right? Diabetes, etc. In other words, we have to, in the longevity industry, this is very important to me. In the longevity industry, we always have to think about, okay, what is killing us today? Which is by far, it's these things. Almost certainly, if you take a random person, even someone in longevity, and you say, what is this person going to die of? Right? They're almost certainly actually going to die of cancer. And often what happens is these chronic conditions are actually encoded in our DNA. And so this is what's so powerful, because we can get a baseline risk assessment of every common disease. And then we can start thinking about the entirety of our protocol to basically help prevent or mitigate that condition. And there's extreme cases here, right? For example, like my cousin who had the long QT condition, there was a very clear drug you should take. For, heart disease, what happens is sometimes someone might say, wow, my cholesterol's so high, but I exercise, but I eat well, but my nutrition's good. Why is that? Turns out it's genetic. And then they should consider different, medicinal options more immediately and more readily than someone who doesn't have the same genetic disposition. For me, another great example was I'm actually really high genetic risk for schizophrenia. Crazy, right? But even you can be really high genetic risk for schizophrenia, but still have a really low overall chance. But still, for me, I said, okay, you know what? I've personally never done any drugs, but I'm going to continue to never do any drugs, right? Because there's a reason why you give people the same drug, psychedelics, it can have very different effects. That's actually because of your DNA. In other words, it's a baseline assessment. Hemochromatosis is another good example. There are customers sometimes with very high iron levels, and they don't understand why. It turns out they actually have a genetic condition that increases their iron levels a lot and gives them a lot more clarity in what and how they need to do to actually manage the condition. So genetics is not a silver bullet, but it has very clear medical actionability steps that anyone and everyone who's interested in longevity should take and incorporate into all their protocols. And that's why also on your point on Brian, Brian, we were the only company that sponsored every single Don't Die Summit. There's actually a great video. Look it up. Look up Brian Johnson takes DNA test in San Francisco. There's a video of me and Brian on stage, like having a great time. Have you seen that? Have you seen that video?
I have
great
not,
video.
but
You
I've
should
been
watch
at
that.
Don't Die in New York. So
nice. Okay, great. Yeah, we were there. We had a nice booth there. And the thing with Brian is that if you think about Brian, like the foundation, one of the first things Brian actually did, I think it was back in 2008. He actually got his whole genome done. Back then, it was like crazy expensive, man. It was crazy expensive, but he actually got his whole genome done. And so that sits at the foundation, which is, hey, is there anything really bad in your DNA that we can identify that would actually, they can shape your entire health protocol, your medical interventions, and your entire longevity stack?
Yes, it's crazy that it moved so fast that in the past you would have to go an extra mile, like what Brian did, and today it's available to everyone.
It's available to everyone. I mean, that's the wonders of technology. That's why Nucleus exists. That's why we're here.
So you talked about doing the analysis and then basically telling people what they are, what they have risk factors for, what they are predisposed for, etc. But you also talked about some of the things that are describing their health at the present time, right? So do you combine it with blood tests, etc., to find out because one thing is what I would consider the starting point that you have, right, the DNA, but then you also need to assess where you are at currently so you can actually decide how you want to go about things.
Yeah, absolutely. It's a great question. It's one of the most innovative parts of our platform is that we don't just analyze the entirety of your genome. we also look at every relevant non-genetic piece of information too. For example, let's go back to heart disease. People know heart disease isn't just genetic. They know LDL, they know sex, they know smoking, they know BMI, they know all those other variables influence someone's risk, right? And so the one of the most innovative parts of our platform, which I think is very underappreciated, is we actually combine your entire genome with every one of these pieces of non-genetic pieces of information, right? So when you sign up, you actually give us your LDL, you give us your A1C, whatever, and we then take all this information and combine it to integrated risk models that then calculate your unique risk. And this is so powerful because if you took a condition like breast cancer, for example, and if you had a male with a genetic marker and then a female with the same genetic marker, their risk for breast cancer would be very different, right? The female's at 60%, the male's at 2%. In other words, the non-genetic information combined with the genetic information really matters. And this is where, LDL and genetics has an interaction. Also, if you look at other variables, obviously age is the main one, sex is another one, right? That really we build these integrated models to give people risk assessment. So in your case, for example, we would consider the fact of how old you are, how much you weigh, your sex, specific different biomolecules that we can measure that you can give us. And we take all of this and then we give you risk estimates based off that. And so it's one of the coolest parts about the application. And then you can imagine how we're going to eventually build this out in the future, because it's going to say, hey, Kian, as a 25-year-old male living in Brooklyn, wow, you had super high LDL levels in your last blood test, which I do, by the way, unfortunately. But that's actually no surprise because you're in the 95th percentile for your genetic risk for high cholesterol. We found people with similar sex, age, and genetics as you saw, 10% reduction to LDL levels when they did this specific workout tracked on your Apple Watch, right? That's the power of precision medicine. In fact, when you measure the deduction in LDL levels, you can then see the corresponding decrease in risk from someone getting heart disease. So we can actually tell you today, hey, if I brought my LDL levels down by, 10 points, how would my risk for heart disease change? It would say, hey, your risk for heart disease comes down by, 10%. That's the power of precision medicine. That's the power of where healthcare is going. And we're very excited to be leading that future.
You mentioned doubling the lifespan expectancy in the next, I think you mentioned 150 years or something like that. And you mentioned the chronic diseases that we face today. What do you think it will shift towards? What's going to be like, if you could just fast forward into the future, where do you think this is all going to end up in the next round?
So for like in the context of how do we continue to extend longevity, like where's all the technology going to end up?
Not like what are going to be the other limitations later down the road, right? What do you think we'll encounter? I know
after
that
chronic disease.
Predicting the future, yes.
Well, I think the thing with chronic disease, which is so interesting, which is it really seems to be, the thing with bacterial infection is that when someone would die, this isn't necessarily always true, but this is kind of generally true, especially if they were younger, they'd be in very good shape, right? They'd be strong, they'd be healthy, and then their health would like kind of collapse. Oftentimes with chronic disease, we know that the disease of aging kicks in. Right. So maybe there's a world where in order to fix chronic disease, you have to fix this, disease of aging. Maybe there's that world. I would suspect that if you actually integrate the current technology we have today with kind of more preventative, earlier diagnostic testing, you could easily save, years, if not honestly decades of people's life expectancy, because there's so much of it can be caught early, especially with cancer. If you catch cancer early, the probability of you surviving is just dramatically higher. I do think there's going to be sort of probably frontier genome editing technology that's going to enable people to live much longer lives. I mean, obviously genes plays a strong role in basically every common disease. And so I can see a future where, that becomes much more sophisticated. I can also see a future where AI basically combines with genetics and we have such a deep understanding of the human genome that we could literally optimize every single letter to basically increase our longevity. And that will just be almost like a pill, longevity pill, right? You just take I want to live another 10 years, pop. And people are going to, there's going to be these wonders of science that we don't even appreciate. Like today with drugs, people don't appreciate that. They take a drug and then the pill is completely abstracted. It's like a genius of science that's abstracted. Eventually, I think that's going to be true for longevity as well.
That will be an interesting future indeed. Let's get to talking about what makes you so happy and pumped today. You had a big announcement.
Oh man, yeah. So this is awesome. One of the things about Nucleus as a company is that we don't just build tools that let people be healthy. So when you do our DNA test, again, going back to the 1,000-page book, we look at all 1,000 pages of your DNA. Obviously, your DNA doesn't just impact your own health, which we analyze for, but also can impact your future children's health. And so we've actually developed the first of its kind software that lets you combine your DNA with your significant other, your partner, your girlfriend, your boyfriend, whatever, and you can actually see the combined risk over 900 conditions that you can pass down to your children. So this is so, so, so powerful because now finally, one of our missions is to build software that starts to happen to my cousin to happen to anyone in the world. And so, when I think about what we're launching here, we're basically empowering couples with tools that lets them have healthy children. And, we had a massive launch on Twitter today. And I think that a lot of the times our customer base is starting to appreciate that when you sequence your genome, you get lifelong insight. It's not just about, oh, here's my disease risk here for these conditions. It's also about your family. And it's also they're going to see about how your DNA affects your metabolism of different drugs as well. We always endeavor for the highest clinical quality, the most scientific rigor as possible. And so I think, introducing nucleus family or family planning through genetic matching is such a powerful testament to our product.
How do you actually go and work with the community effectively to make sure that when you do these launches, that everything is well tested and well adopted by
a lot of work.
The people out there?
A lot of work. There's a lot of constituents in Nucleus, right? We have physicians, we're a physician order test, we're, a medical provider, we're CLIA certified, we're CAP accredited, we're HIPAA compliant. We have obviously our customer base first and foremost, so we kind of span different, kind of regulatory and kind of HIPAA requirements that we have to comply with because we're very stringent with the way we treat and handle people's information. And so, as we go kind of think about launches, we are we take great pride in this company kind of being both really scientifically rigorous, really careful, really deliberate, but still shipping for customers. And this is really important because a lot of genetics companies historically, maybe they would look at your DNA, then that would be that. Right. But actually the genome has so much data, so much information, someone hasn't really properly analyzed, interpreted, and given to people. And that's what I'm very proud of is that we're the true software for your DNA. It is here. The software for your DNA is here and it is in Nucleus. And so you can see a world where literally every single person in the world is going to get their genome sequenced and get these life-saving insights. And that doesn't just mean disease risk. It also now means family planning. So they can have healthy kids.
For sure. How do you balance out the two approaches of shipping things fast, breaking things, and making sure that you are in biotech and in the end it's an industry that probably deserves a little bit more care?
Absolutely.
That when you put something live, it's not gonna harm anyone negatively.
Yeah, so because we're a medical provider, our test is shown to have 99.9% analytical ability. In other words, we're very confident in genetic markers. If we call a genetic marker, we know we're calling it. So we've done a lot of internal validations of our testing, of our analysis, of our pipelines. And so we are, software engineers at heart. And there's actually very few people who are better than software engineers in creating systems in place that mitigate error and risk, right? But if you actually think about like a traditional human being that would interpret genetic results, it's much more error prone, right? There's a human being, you actually, they could maybe overlook something, maybe they're tired. Doctors as well, actually. Doctors sometimes, they have a failure case, they have an error rate. But making things more systematically and more kind of algorithmically and using the wonders of software, we do have some humans in the loop. We do have clinical geneticists that review certain kind of flag markers because it's still very important to make sure the quality of results. And that's actually a great example of what we do as a company, right? We do a lot of automation and we do a lot of kind of different kind of validity tests, but then we also still have actually clinical geneticists to ensure that the quality of results are going out, especially if it's a serious result, meets our clinical standards as a laboratory. So this is sort of the kind of magic of Nucleus and getting that balance right. And something that I think we've done extremely successful at, and I think we're going to only kind of continue to accelerate as we continue to grow the product and better serve our customers.
What would you say are some of the directions where you would like to evolve the product further if, it's not something that you would like to keep secret?
No, let's talk about it. So one of the things about genome is, we talked about disease risk assessment. We talked about family planning. I'll talk about a couple more things about family planning. One is that we're really focused right now on kind of hereditary disease risk. So what hereditary disease risk is it will tell you something like, oh, will my child have this will we pass down this, kind of more rare genetic condition, right? Because what happens is mom can have a bad genetic marker, dad can have a bad genetic marker. Mom's genetic marker doesn't impact her health, dad's genetic marker doesn't impact his health, but then combined, it could impact the baby's health, right? So that's kind of how classical genetics works. But also, there are conditions that are, as I mentioned earlier, that are driven by not just one marker, but a million. So we're actually building out simulations of people's babies, so you can see not just their disease risk, but also things like their height, for example, even like the hair color, eye color. So we're building kind of full stack baby simulations, actually. So it's actually going to be really exciting. That's all part of that. That's coming out soon. I know, right? It's pretty cool. Next thing is also, yeah, go ahead.
No, I just wanted to ask what would be the probability that you'll be able to assess the
Yeah.
height correctly, or
Well,
color of hair, or color of
it,
eyes, for example.
yeah, it depends on the phenotype. It depends on the trait. For example, something like height, actually, the models are really good. And as you can guess, too, if you think about genetics, right? If I asked you, how genetic do you think height is? You'd probably say it's very genetic. If I asked you, how genetic do you think lung cancer is? You'd probably say it's less genetic, right? Because maybe it's like driven by smoking or the like, right? Or gastric cancer or skin cancer, right? Skin cancer is more driven by the sun, for example. And so intuitively, people know that different phenotypes are driven by different degrees by genetics, right? So also you're asking the question, which is how genetic are different traits as well, right? And so then always the way you want to measure genetic models is like, okay, you can never predict height perfectly from from a genetic model, and you know that because guess what? Let's say I took identical twins, and then let's say I took one twin, I didn't feed them right, right? I didn't give them enough nutrients, whatever. That twin's going to be shorter than the twin that got more, food and was properly
Right.
nourished. Everyone knows that, right? So in other words, there's always error with these models naturally. And there's also even some genomic error too, because we can't build perfect models. But we're very good at communicating that, so you can actually understand as a parent which direction, on average, will your baby be? Will your baby be slightly taller? Will be slightly shorter? Will your baby's risk be higher or lower? And that's kind of the beauty and the kind of communications that we do in kind of presenting what signal we can actually get from the genetic information, which if the trait is more genetic, like height, for example, we can actually get quite a bit of signal. The height model is very good. And that's why parents we already have some beta customers. They really like using that product to see. And so, that's a cool feature that people, are starting to understand. Wow, this is like an emergent property of building a whole genome company, is that you actually are not limited in your application.
I just started thinking about dating apps because over my career, I have worked from probably 20 different dating apps. So
Wow, really?
I thought, yeah, like majority of them out there pretty much. I mean, the big ones. But yeah, it'll be interesting to basically see that, because like the most successful dating apps are usually based on like a niche or something like relatively specific where people connect, and this could be yet another thing. Even when you are, if you are thinking about dating seriously, you could plug that in. Have you considered anything like that? Anyone reached out to you so far? Or
Yeah,
the
actually,
the
they have.
feature is so new?
No, no. Let's just say that one of my goals actually has been to integrate DNA with dating apps. That's actually something that I think we do, and I think it belongs to the liberty of the patient. I think, for example, customers should decide whether they want to be matched with someone or not who has a genetic marker that is equally as bad as them. Because maybe they don't. I mean, there are communities in the Ashkenazi Jewish community, for example, they actually don't match people who are both carriers for the same bad genetic marker. And so there's
Yeah.
a world where, you say, okay, I'm on a dating app. I don't want to be matched with someone. I mean, if I don't know someone, why would I want to be matched with someone who has the same bad genetic marker? It's so rare anyways. I don't want that. Right. So you can
Right.
opt in, and then you opt in, and then at a population level, you'd actually screen out any hereditary disease. That's, I think, really interesting. I also think then you could go one step further and you could say, hey, imagine what our babies would look like. Click here to see our babies. Click. You simulate. Boom. It's all software. So like
Yeah.
I actually think it's
Right.
gonna. I think Lubo, it's gonna happen, and I think we're gonna actually pioneer it. Honestly.
It would be kind of cool that you could just swipe. Okay, what are the options? Oh, this could be my baby. This
Yeah.
is what
Kind of cool, right?
she would look like, and now I have to find the right mom for it.
Exactly. Exactly.
What are some of the other ideas out there that you have for Nucleus going forward?
Well, one of the things is pharmacogenomics. So pharmacogenomics is how your DNA affects your metabolism of different drugs. This is a highly in-demand feature. A lot of people want this feature. They want to know, hey, if I take this drug, how does it impact me, right? What dosage is right for me? And this is obviously very actionable, right? Because once you get your genetic insights, if you ever need to get prescribed a drug, you can cross-reference it against your DNA to make sure it's the right dosage for you. So, I mean, that one needs no further, I think, explanation. It's just such a clear, actionable use case of genetics.
Yeah, that's like it can go beyond and beyond. I believe that you are onto something that will not stop for quite a while at this point, I believe.
I agree.
Uh, what were some of the things that you have changed in terms of your own personal habits and routines? Because I assume that you have studied your reports and you have used yourself as a guinea pig for a little bit. So, what's been some of the insights that you have tested on yourself?
Yeah, no, it's a great question. A lot of things. One is I've had always bad migraines, and I actually never knew why. And it turns out it was actually genetic. Interesting that. Um, and if you actually you can take vitamin.
I think it's a destiny.
That's actually funny. You can take different like supplements like vitamin B, riboflavin, etc., and then you can actually help like alleviate headaches. This is like different like techniques you can use. Because I actually never knew why I had headaches. I thought maybe it was sleep, maybe it was something else, but it wasn't actually. And that actually has been very insightful for me because again, it's about like understanding what the causal thing is, so you can understand what the downstream step you should take. I mentioned schizophrenia earlier, where again I've never done any drugs, but now I knew this information. I was like, okay, I'm never going to do any psychedelics. I need to stay away. It could really, trigger you and could, the old thing about one shot it could, one shot you. And, that's like obviously could save your life. I mean, that's the thing with genetics too, which is some of the actionability you get and the insights you get literally save your life. I mean, that's pretty amazing. Another great example is I'm actually a cystic fibrosis carrier. So it turns out that, it's just, I don't have cystic fibrosis. However, if my child inherited a copy from his mother, right, from me and his mother, then he would have then he would have the condition. And I had no idea I was even a cystic fibrosis carrier until I actually did Nucleus, believe it or not. And cystic fibrosis is actually pretty common. It's 1 in 25 people. And so when I think from that perspective, I'm like, God damn, like, like now, whoever my future partner is, I'm going to say, look, you need to get a genetic test done. I mean, I don't want to have a kid with disease, God forbid, right? I mean, we don't want that. And here's the thing, though, if you're a couple and you both are a carrier for the same genetic marker, it's perfectly okay because you can then do different reproductive options like IVF to basically completely avoid the risk of getting the condition in the first place. So, really, the entire premise of genetics is like, hey, you identify the risk and then you prevent it. That's the beauty, right? That is the beauty of precision medicine, which is before the baby's sick, before you're sick, before you have to then treat you millions of dollars of potentially in cost and insurance and pain, you prevent it altogether, right? And you can do that with a swab. I mean, a swab, it's just like, it's such a no-brainer. It's amazing.
Super easy.
Yeah, it's super easy. Exactly.
Well, at the beginning, we talked about you being stuck in your bedroom, thinking about how to build it up and how to basically absorb all the information out there. Well, you are still extremely young, but I believe that a lot of things changed because you are surrounded by very knowledgeable people. You have connections, etc. How do you what are some of the sources for inspiration and further growth, how you work on yourself these days?
Yeah, there's always room to grow. I mean, every day, I'm a work in progress. Um, I think that I like to always look at some people who are kind of, maybe 5 to 10 years older than me who I look up to. And you probably don't know their names, but they run companies and they have a, good kind of passion and intensity and love of their product. They have great marketing instincts, they're great technologists. They have kind of this polymath-like ability. That I think I always respect. And it's always like, you always know the people before they hit kind of escape velocity, right? Before everyone knows who they are, you kind of have a relationship with them, which is really nice, and they can kind of give you guidance, etc. Which is different than being like, oh, Elon Musk or Sam Altman or whoever else, right? Though I do think that there's still things to learn from those people as well. I mean, Elon, I think, is the greatest example of someone who just is so scrappy to the maximum degree. I mean, he has taken scrappiness to a level that I don't think has ever been seen in Silicon Valley. And you can love Elon, you can hate Elon. I don't necessarily agree with everything Elon does, but you gotta it's like you gotta recognize how good Jordan is. You gotta recognize how good Elon is. Like, oh my God,
There's no way around that.
there's no way around it. It's like N of one. And so these are some of the things. We have obviously a great investor bench, right? Alexis Ohanian, founder of Reddit, for example, is one of our investors. I mean, just brilliant. I mean, I love Alexis. So kind, so gracious, so smart, but still a killer. He's from Brooklyn as well. He's got the good genes, if you will. He's got the good mix of, and so I look for a lot of different places for inspiration. I try as a general rule not to take too much inspiration from one place, honestly, because we're all kind of, broken creatures a little bit. And I think it's important to take the best of people. I think people aren't perfect, and I think people aren't perfect, but the art is perfect. That's the way I think about it. So,
Do you geek out with any other like longevity things that you could do to optimize your health, etc.? Or
well,
do
I
you
was
kind
at,
of
at the at
stick?
the Brian Johnson summit, so I've been to all of them, and the founder of, oh my God, the company's escaping me, but he sells the red light therapy. If I remembered his company's name, I'd give him a shout out. But I sold his red light therapy, and I put it on my back, and helps quite a bit. So I can recommend that red light therapy if anyone's looking. That was
Was
something
it
that was actually interesting.
was it Restore or another one?
Yeah, I think it was Restore actually. Yeah, I think it was Restore.
Yeah,
Yeah,
there's so many of these
I think it was Restore.
that popped up recently,
Yeah,
but
Restore is good. I like the founder. He's a
yeah.
nice dude. That's cool. There's different clinics that people go to. Sometimes I get invited to them. As a general, I mean, I work out every day like a maniac. I mean, I work out every day. I love working out. I mean, just being strong, feeling good. Lifting heavy.
What's your workout of choice?
I love squatting. I love deadlifting too.
Yeah.
Yeah. I mean, I love sports. I mean, if I was going to be like, I mean, I used to play soccer somewhat, pretty competitively in high school. I played tennis at some point. In college, I tried to pick up squash, which was fun because I would dive headfirst into the wall, and all the kind of preppy kids would be like, what the hell is this guy doing?
Well, next time I'm back in New York, we have to hit a workout
Let's
then.
do it. Let's do it. Let's go.
Well, Kian, thank you so much for a great conversation. A lot of valuable insights. You keep killing it. I'll be
Thank you,
watching
brother.
from the sidelines and we'll be in touch.
Thank you, brother. Thank you, Lou. Appreciate it. Thank you for having me.